or 240,000 miles from Earth. It will take the Artemis astronauts about 5 days to reach it, every moment trusting their lives to the hundreds of engineers who designed and built Orion's protective systems. Beyond Earth's magnetic field, the spacecraft will be exposed to the dangers of deep space. Intense radiation and high-speed particles from the sun can damage both electronics and human bodies. Artemis has been designed with these challenges in mind to bring our astronauts safely back to Earth. Artemis is not an end in itself, but just the first step towards a sustainable future in space. For this reason, NASA is leading development of an orbiting spaceport called the Lunar Gateway. The Gateway provides a rendezvous point for landers, cargo, and supplies needed to support operations on the lunar surface, and extra living space for visiting astronauts. Constructed by robotic missions in years leading up to the astronauts' arrival, it will be used by both crewed and robotic spacecraft. The Gateway has an unusual orbit. Every 7 days, it dives within 3,000 kilometers of the moon's surface before looping back out to 70,000 kilometers. This orbit keeps in radio contact with the Earth while also allowing contact with the far side of the moon. It takes less fuel for departing spacecraft to escape the moon's gravity. It's also easier for arriving spacecraft to meet up with the Gateway. Close to the moon, the Gateway will help with logistics of shuttling astronauts, robots, and materials up and down from the surface. Fitted with its own thrusters, the Gateway is really a spaceship and can adapt its orbit as required for different missions. At the same time as the Gateway is being prepared, private companies will be landing a series of NASA science instruments and technologies on the moon through the CLIPS initiative. The Commercial Lunar Payload Services Program will help perform science experiments, test technologies, and demonstrate capabilities to help NASA explore the moon and prepare for human exploration. CLIPS missions include tests of a LiDAR precision navigation system. Stick temperature changes, abrasive moon dust, and space radiation are just some of the challenges. So, for much of their stay, astronauts will be protected inside habitats underneath the lunar regolith. It's safer below the surface of the moon. From here, they will use telerobotics to control robots up on the lunar surface. It's also safer above, orbiting high overhead. From the Gateway, astronauts will be able to
people. It's like tornado simulation.
Let's see. So there are actually quite a few more constellations than this. I know somebody mentioned Perseus, so I'll bring that one up. It's over here on the sky. There's Perseus with Medusa, Medusa's head, because the story is that he killed her. And we can't see Orion right this second, but it should be coming up. It should be visible soon in the year. So we can keep a lookout for that one. But you can never see Orion at the exact same time you can see Scorpius, which is this constellation over here, which is one of the zodiac constellations. So does anyone know how many constellations there are in total?
200.
No, that's a very specific number. Yes, there are more than 10. There are in fact 88. And we can see more like 44 of them at one time because we are in just the northern hemisphere. So I will bring those up.
Wow.
Here we are. So, and then I'll bring up the drawing so you can see what each of them represents.
Wow, so
in purple
pretty.
are the zodiac constellations, which make a band across the sky, and in popular culture, people are pretty interested in these and which one is in the sky when you're born. And then we have many other constellations. We have Cygnus the Swan, we have Hercules over here, we've got Pegasus, and this here is the Great Square of Pegasus, which is pretty easy to see usually, Andromeda and Cassiopeia. And I always like Draco the Dragon up here as well. And so when we're looking up from Earth, the constellations look like they make these nice flat shapes, but when we fly out through space, we can take a better look at how the constellations look from space as well. I think it's time that we head off of Earth and take a look at the solar system. Oops, Scorpius is still there, but that's okay. Alright, here we go, and you can get right side up. Alright, so here is Earth, and you can see that half of Earth is in nighttime right now, the other half is in daytime. Over here is the East Coast, where we are, and then as we spin around, you can see South America and Africa. And the Earth looks pretty lonely out here, but there's actually quite a bit more stuff around it. Can't quite see. So each of these orange dots represents a bit of debris that's orbiting around the Earth. So there's actually quite a lot of space junk out here. And these are things like bits of rocket ships and satellites and bits of trash that are broken off of those things when we send them up into space. This is actually causing a bit of a problem because when we want to send up new things, we really don't want them to hit any of this garbage that's floating around. So there have been discussions about ways that we can clean up some of this space garbage to make room for all of the additional things that we are sending out into space. I think there's about 35,000 of these objects that are larger than 10 centimeters here. So I'm going to bring up this distance so we can keep track of how far away we're getting from Earth as we travel away from it. So go ahead and start moving away, and the next thing we want to look for is our moon. So this is the moon's orbit around the Earth, and here's the moon. And a particularly cool thing about the moon is that it orbits around its axis in about 27 days, and it also goes around Earth in about 27 days, which is why it looks like we're just looking at it at the same face no matter where it is on its orbit around the Earth. And that's why it looks like it's stationary. So next, we're going to look at some of the planets. So we can look at the planets in our solar system. So here, the blue line represents Earth's orbit, and then we can see closest to the sun is Mercury, then Venus, then Mars, and then there's this big gap. And inside of this gap is something called the asteroid belt. And asteroids are big rocks that are primarily in this asteroid belt, here in this area between Mars and Jupiter, and they're orbiting around. And something I like to describe to people is the difference between asteroids and comets and meteors, because I know that's something that confused me for a long time. So asteroids, like I said, big rocks, whereas comets are big things made up of rock and ice, and they come from further away, and when they get in towards the sun, they start to melt, and that's why they have those nice trails that we think of when we think of comets. Whereas meteors are smaller bits of debris, and when they get into Earth's atmosphere, they start to burn up. And that's when we see things like shooting stars, which I can show you a bit more of when we get back to Earth later. So now we'll move out a little bit further to take a look at some of the other planets further away from us through the asteroid belt. So I'm going to fade away the asteroids so we can get a better look at things. So next, we've got Jupiter, Saturn, Uranus, and Neptune. And then you may wonder, what about Pluto? Now, by now, most people know that Pluto is not a planet. I did bring it up here, but I will explain to you a little bit more about why Pluto is a dwarf planet and not a planet. So, as we orbit around, we can see something that's different about Pluto relative to the other planets. So you can see that they're all the other planets have this nice disk of orbits that they make, where they're all lined up like this, whereas Pluto is way off on this different axis like that. And this is more similar to these other dwarf planets that I brought up here in orange. And all of these planets, as well as Pluto, are actually smaller in size than our moon. And so you can see how it wouldn't really be fair to call Pluto a planet and then not call all of these other dwarf planets as well. And also, they're just quite different in their characteristics from the planets like Earth and Mercury and Neptune. So, while we love Pluto, we have to call it what it is, which is a dwarf planet and not just a planet. So, it seems like we're out of the solar system by now, but there's actually one more thing, and I'm bringing it up here. This is called the Oort cloud. And so the Oort cloud is made up of rocks and ice, and this is where comets come from actually as well. And so it's a big spherical shell of these objects where comets come from. And so as we move out through the Oort cloud, I'm also going to bring up the constellations again. So if you notice, most of them are still shaped the same that they were before. We've got Ursa Major, Ursa Minor, we've got Draco, we've got Boötes over here and Hercules, and they all look pretty similar. But watch as we move further away and see if you notice what starts to happen to them. There we go. Alright, so what we can see is that instead of being flat shapes in the sky, the constellations are actually three-dimensional. So some of the stars are much closer to us than you can see when you're just looking up from Earth. And so this weird spiky ball makes up most of the stars that are visible to the naked eye. And then, does anyone know what this is that we're starting to see? Yeah, it's the Milky Way. It's the spiral galaxy that we are part of. So, there you can see the bright part is the center of the Milky Way. Does anyone know what's in the center?
Black hole.
Yeah, it's a black hole. So the black hole is called Sagittarius A, and I'm actually going to bring up a picture of it. So, this is what Sagittarius A looks like, and in the center here is where the black hole is, because black holes don't emit any light, but all of the stuff around it that we're seeing in the picture are things that are orbiting around it, like stars and ionized gas that are emitting light. So it may seem scary that there's a black hole in the center of the Milky Way, but it is not a problem. Black holes are just really dense, and so things orbit around them, and if they get really close, they fall in. But it doesn't have like a magical suction power where everything just falls into the black hole. It really just helps maintain the structure of the galaxy. So, don't need to worry about it. Alright, so as we move further away, once again, it seems like, it seems like we are outside of the Milky Way, but there's actually only about 10% of the Milky Way's mass is in this visible part that we can see, and then this larger sphere represents the dark matter halo, which is matter that doesn't emit light, and we're not really sure what it is, but we can tell because of physics that there is a lot more mass in our galaxy than what we can actually see. So, and that's what we call dark matter. So now I will bring up our neighboring galaxies, which are called our local group. And so these are other galaxies that are close by us that are gravitationally bound to us, meaning that we're all interacting via gravity so that we stay together in this group, kind of. So the closest spiral galaxy to us is called Andromeda, and that one is actually on a collision course with us in about 4 billion years. But again, it's not something we have to worry about, firstly because that's a very long time from now, and secondly because on the scale of how small we are on Earth relative to us orbiting around the sun, it doesn't have anything to do with the galaxy and what will happen when the galaxies merge together. It'll just form a new galaxy shape, but the Earth will still be orbiting around the sun. So now what I've brought up are other local groups. So each different sets of colors here represents another local group of galaxies. So these are the other groups around us in something called the Tully survey. And as we get further away, bring up another survey of galaxies, and this is galaxies from the Sloan Digital Sky Survey. And this is the largest 3D mapping of the universe that we have to date. And it has this weird shape, kind of like a bow tie, if you notice. And that's because the axis of the Milky Way goes through like this. So if we look out this way, we're looking through all of that stuff in the Milky Way, and it's hard to see. But if we look out through the top, we can have a much better view because there isn't all that stuff to block us. And so this is looking out through the bottom, but then all around there in the bow tie shape, that's because of the Milky Way. So there's one more thing out here that I want to show you, and that is the cosmic microwave background. So essentially what we're looking at here is a baby picture of the universe. So this is a mapping of radiation that comes from a very, very long time ago, just a little bit after the Big Bang. And it comes from really, really far away, which is why it's taken so long to get to us, that we can essentially look back in time to what was happening a long time ago, very far away. And this tells us things about how the early universe formed back near the Big Bang. So outside further than this, it's not that there's nothing out there, it's not that we just can't see it yet, because it just takes a long time for things to get to us. It's from signals that are really, really far away. So this is the edge of the observable universe, but with better technology and more time, I'm sure we'll find more and more things and make bigger and bigger maps of the universe. And now we'll go ahead and start heading back towards Earth and maybe stop at a few planets on the way home. So I'll remove the cosmic microwave background and the Sloan Digital Sky Survey. So there are the Tully groups of galaxies, and then there's just our little local group. So this can help give you a sense of just how small we are relative to the observable universe. And then if I take away the local group, you can see just how small the Milky Way is. So small, we can't even really see it right now, but I promise it's still there. Back we go into the Milky Way. And on our way back, there's something else that I want to show you as well. So there are the stars that are visible to the naked eye and making up the constellations again. Go ahead and fade those away. So one of the last things that I want to show you are nebulas. So nebulas are clouds of gas that come from dying stars, and they make some really beautiful shapes. And a lot of the really nice pictures you might see of things going on in space are oftentimes nebulas. So take you to see one called the Twin Jet Nebula. Alright, so we will be headed out through this constellation to go see it. This is Ophiuchus. And it's called the Twin Jet Nebula because you can see there are two big jets of the gas that are coming off of the dying star. So there it is. Sometimes people call these butterfly nebulas as well.
So pretty.
Bring it down so you can see it a little better. I think they're just, even though they're not necessarily as interesting as black holes and dark matter, they're really beautiful to look at. So. Maybe a little further away. So now, I'm gonna take us back to our solar system. And does anyone have a favorite planet they want to stop at on their way home?
Saturn.
Okay, I heard Saturn. Saturn is also my favorite, so we will start with Saturn.
What's your favorite?
Earth.
Yeah, it's home.
Yeah, we can go to Jupiter too.
Let's go to Jupiter.
So I think what people always know best about Saturn is about its rings, and that's one of the things that makes it special are these beautiful rings that it has. Let's get a big rim which are about 1,000 times as wide as they are thick. So the rings are quite thin. There we go. I think my favorite fact about Saturn is that it actually has a storm on it that's shaped like a hexagon. It's a little bit hard to see in this 3D model, but I'll show you a picture of it. And we don't know why it's actually shaped like a hexagon, which is good. I always enjoy a good mystery. So this is a picture of what it looks like. And so people are still trying to model why it's like this.
Oh, that's interesting.
It's northern pole. Alright, so why don't we go to Jupiter as well, since I also read that one. And Jupiter is, of course, the biggest planet in our solar system, which is good because it has, on occasion, blocked comets from getting close to Earth. We hit Jupiter instead, so Jupiter
It helps
is a good
us
friend
to
of ours.
prevent comet falling in our heart.
So, there's Jupiter's big red spot over there, which can fit 3 Earths inside it.
Oh my god.
And Jupiter also has some pretty cool storms going on.
It looks like pizza.
These eight
Yeah, take picture.
I also have some nice
taking video.
pictures of Jupiter from the James Webb Telescope, which is one
It's like
of the
pepperoni.
new telescopes. Let me see if I can bring up one of those pictures. So it's a new telescope that's been sent out into space that's been taking a lot of pretty cool pictures that people have been getting excited about. Oh, Mars? Yeah, we can go to Mars too. So these are some of the pictures of Jupiter from the James
This
Webb
little kid
Telescope in different
Very interested.
measurements of measuring different wavelengths of light, which is why they look different. But you can also see its moons next to it. You can see Europa quite brightly next to it as well, which is pretty cool. Alright, so let's go to Mars. Alright.
Someone said take two.
Mars is one
Take
of the
them all,
planets that
like,
we've sent
let's go
a lot
to
of
all.
stuff to, because it's relatively close to us and it's also a lot more hospitable than Venus, which has a super thick atmosphere, super hot,
so
and
happy
it's
to be
hard to
here.
send things there without them just burning up there.
So much information.
So here's Mars, and I can also show you some of the places where we've sent things to on Mars. So here are the landing sites from some of the Mars rovers, like Curiosity, Insight, Spirit. So Mars is also famously red. I would say that this model of it doesn't look particularly red, but when you see it in the night sky, it also looks a bit red as well. Alright, so I'm going to go ahead and take us back to Earth now, and we'll look at just a couple more things, and then that will be our show. So let's head on home.
We see our home.
Alright, and then we're going to land on Earth again.
We're gonna go to Pittsburgh from here.
And there we are, right back at home. So, one of the last things that I want to show you is look around and see if you spot any shooting stars. I think those are one of people's favorite things to look for when they go stargazing.
Shooting stars.
So shooting stars are actually meteors, which I mentioned earlier. And one of the biggest and best meteor showers is actually located in the constellation Perseus. It's right above his fist is where it comes from, and that meteor shower happens once a year, and they are called the Perseids. And they are coming from the trail of a comet that's actually been called one of the most dangerous objects to mankind, because it's a comet that actually it's really large, and it gets quite close to Earth's orbit as well. But it leaves in a trail of meteors coming towards Earth that make a beautiful meteor shower once a year. I think with that, that's probably all the time we have for today. So I'm going to go ahead and let the sun come up, and we'll go about
Listen,
Come.
After the meteor shower.
Comet.
come, what's here?
Imagine technology after 100 or 1,000 years later, how it would be so good. I wish I was alive that time. Not now. That time.
We were born again.
I don't believe in that.